Working on examples in chapter 6.6, which talks about graphing systems of inequalities. So, solve by graphing. I have these two system of equations. I need to, in order for me to graph, I need to set it into y equals mx plus b form, right? That's the easiest way to do this. So I'm gonna go ahead and do that. This one's already set up that way, but this one isn't. Remember, y equals mx plus b. Y equals mx plus b. For those who need a little bit of freshening up, m is your slope, b is your y-intercept. Okay, so here I need to leave the y by itself, so I'm going to bring that x to the other side of the equation or inequality. So if this is a positive x, I have to subtract x in order to make this 0. So I'm going to subtract x to the other side as well. Okay? And I end up with y. I keep the same sign of the inequality because I didn't multiply or divide by a negative. So it stays the same, greater than or equal to. And I have a negative x plus a 1. Okay. So this is the proper form I need it in, slope intercept form. So let's graph. Let's start off with this one. I have a y-intercept of positive 1. So that is where my graph is going to cross the y-axis. Sorry. So with the blue marker, I'm going to symbolize this equation, and it crosses here at positive 1. Okay, not here because that's your x, but here because this is on my y, and that is your y-intercept. Okay, then I have a slope of negative 1 over 1. Okay, because there's an imaginary 1 in front of the x, right? And any number is over 1. So I have a negative 1 over 1. That means I'm going to go down 1 to the right 1 because it's rise over run. So here we go. Here's our next point. Okay. Then down 1, right 1. Down 1, right 1. And so on. I could also go up 1, left 1. Up 1, left 1. Okay? Because the inequality sign has the little bar, the equal to, on the bottom, right? My line is going to be a solid line, okay? So here, is my solid line, okay? And I have to see, how do I graph y equals 3, okay? When I graph that, that means it's crossing the y-axis at 3, okay? It means that at any point on that graph, y is going to equal 3. So that's a positive 3, so that's here on my y. So it's going to cross here, and it's going to cross all of these. Now I'm going to make it dotted or dashed line here because it is not equal to, it's just less than, okay? So you see, at any value here, if I grab this point and I say, what point is that? Well, that is 1, 2, 3, 4, 5, 6, 7 for my x and 3 for my y. So for any x, I still have 3 for my y. For any x, I have 3 for y, okay? That's why it's graphed that way, okay? Now it says y is less than 3. So I'm gonna shade everything that's down here. It's less than, right? So Okay, anything that's below this line is going to be shaded because it's less than 3. Okay, now notice for the other one, I have y is greater than. So I'm shading everything above it. So here for the blue one is greater than or equal to, so I'm shading everything above it. And notice that where they meet, where these shaded regions meet, is in this area. Okay? So that is the solution, because that is where both shadings meet. Okay?